Hello everyone. In this video, we are going to discuss about the unit hydrograph and what are the various assumptions in the unit hydrograph theory, and along with it, what are the different aspects related to it. So let's start. So we were doing the computation for calculation of the runoff value. So if we want to compute the runoff, we have looked at one of the method that is known as the hydrograph, which is a plot of the discharge versus time. Now, this can also be done by using the unit hydrograph theory. So, the method that we were looking till now, that was the hydrograph method, it was helping us in computing the single value of the runoff, which was resulting from a given rainfall. Now, this unit hydrograph theory, it helps us in computing the entire hydrograph of the surface runoff from the rainfall hydrograph. So it must be available with us, only then we can do the calculations for the entire hydrograph. Now, this is also known as the unit graph, which was propounded by Mr. L.K. Sherman. So sometimes this unit hydrograph, it is also known as the Sherman hydrograph, which was given in 1932, and it is a very versatile tool for determining the hydrograph of the surface runoff, which is resulting from any given amount of rainfall excess. That means whatever proportion of the rainfall that has gone down as the percolation, or in fulfilling the soil moisture deficiency, the remaining amount that will flow as the surface runoff, and that is signified, or that is represented by this unit hydrograph. So in this method, we can prepare the standard unit hydrographs which are caused by the rainfalls of the specified durations. For example, 4 hours, 6 hours, 12 hours, etc. Now this is the standard T hour unit hydrograph. So this T may be variable, but this value will be always unity, which is the rainfall excess. Now this unit hydrograph, which is containing 1 centimeter of the excess rain, that is used to work out the hydrograph caused by any other rain of the same duration and containing any other amount of the excess rain. So for example, if we are having 4-hour unit hydrograph and we want to work out the hydrograph by the rain that is also for the 4 hour, but that is having 2 centimeter rainfall. So we can predict that also by using the unit hydrograph. So as the name itself suggests that what is unit hydrograph, so it is the hydrograph of the runoff which is produced by an intense excess rainfall of 1 centimeter. So the term unit here, that is representing 1 centimeter depth of the rainfall, and that must be taken care, which is occurring uniformly over the entire drainage basin or the catchment area when the rainfall was at the uniform rate for short specified duration of T hours. So this excess rainfall is nothing but that we know as the surface runoff. So the volume of the water which will be contained in the unit hydrograph, that will be equal to 1 centimeter depth over the basin area, because this is 1 centimeter, that is the depth of the water into area, that will give us the volume of the water which is contained within this. So the specified duration of the T hour, that was unit duration, and because of which the storm was known as the unit storm. The word unit in the graph, that is hydrograph, that was given to understand for the unit of the time. However, it has been interpreted to stand for the unit depth of the excess rainfall. So if let's say this is the catchment area, Now on this catchment area, there will be uniform depth of 1 centimeter of the water. So at any location, if you check the depth of the water which will be stored here, which will be flowing over this catchment area, that will be 1 centimeter. And this is the representation of the rainfall, that is denoted by P, which is a symbol of the precipitation. Now let's say the time duration, that is the time during which the rainfall is occurring, that is 4 to 7 p.m. Now in this there will be 4 to 5 duration, then 5 to 6, then 6 to 7. So the assumption is that the rate of the rainfall, that is uniform, and that is given by I centimeter per hour, that is uniform rate, and the capital T value here will be 3 hours. So if a storm occurs for 3 hours, the rainfall excess from that runoff will be 1 centimeter. Then the hydrograph for such storm will be known as the unit hydrograph of the 3-hour duration. So in the previous method, we have discussed that whenever we plot the curve of the discharge versus time, we always get certain value and then it increases and then again it recedes down. So in this curve, there was a constant flow which was known as the base flow or the groundwater flow. Now that is not giving us the true picture of the storm that has occurred over the area. So to have the clearer picture, what we do, we remove this base flow from the entire flood hydrograph. So this total one, that was known as the flood hydrograph. So from flood hydrograph, if we remove this base flow, the remaining proportion, that will be this one, and this proportion is known as the direct runoff hydrograph. That means because of the surface runoff. Because of the surface runoff, whatever amount of discharge is happening, that is plotted against time, and that is known as the DRH. That is the direct runoff hydrograph. So from the flood hydrograph, if we write that in the equation form, so from the flood hydrograph, if we deduct the base flow, that will give us the value of the direct runoff hydrograph of given duration. Now this direct runoff hydrograph, let's say if that is representing the x centimeter of the rainfall excess, that is representing the x centimeter of the rainfall excess. So to have the unit hydrograph, because for the unit hydrograph, what was the condition? That rainfall excess, this value, that should be equal to 1 centimeter. Therefore, all the ordinates of DRH, they have to be divided by this x centimeter, or that may be written as the effective rainfall. So this rainfall excess is also known as the effective rainfall, because this is the rainfall which is having its effect in terms of the surface runoff. So this is the equation. So this is the path to obtain the unit hydrograph with the help of the flood hydrograph. Now if we want to move in the other direction, that means if we want to obtain the flood hydrograph from the unit hydrograph, then first of all, unit hydrograph has to be multiplied with the effective rainfall. Then we will get the direct runoff hydrograph. In that, if we add the base flow, then we will get the flood hydrograph. So both the directions and both the outputs have been shown to you so that we can obtain any of these. If we are having the flood hydrograph, then we can get the unit hydrograph, or if we are having the unit hydrograph, we can have the flood hydrograph. Moving on. Now when we do the analysis of the unit hydrograph, there are certain assumptions which are taken to analyze it. So the first assumption in the application of the unit hydrograph, that is known as the linear response. Now what is this linear response? It says that the runoff response of a drainage basin, that means of the catchment area, to the excess rainfall is assumed to be linear. That means if there is certain input value of x1 which is causing an output of y1, and then there is another input value of x2 which is causing another output of y2. So if we combine both the inputs, then we will get the output as the combination of the other two outputs. That means, in other words, an input equal to d times x1, that will cause an output equal to d times y1. So if the rainfall excess of d centimeter, it occurs in a duration of the t hour, then the resulting runoff hydrograph will have its ordinates equal to d times the ordinates of the unit hydrograph. For example, if we are having 1 centimeter of 2-hour unit hydrograph, now this unit is representing the 1 centimeter of the rainfall. Now if we want to plot the 3 centimeter of the same duration of the unit hydrograph, so all the ordinates of this 1 centimeter has to be multiplied by 3, and then we will get the 3 centimeter unit hydrograph. That means all the ordinates will increase by the ratio d, but the base of the hydrograph, that will be same as that of the unit hydrograph, because that is occurring for the 2-hour in both the cases. So hydrograph of any other shape of the specified duration that can be obtained from the unit hydrograph of the same duration, now ordinates that will be changed in proportion to their runoff volumes. Now what does it mean? It means that the principle of the superposition, that can be effectively used if we require n centimeter of the rainfall or the n centimeter depth of the excess rainfall by using the unit hydrograph of the same catchment area. Now what we do in this case, let's say this is the unit hydrograph that we are having. So this is representing the discharge and time, and since we have removed the base flow, so it will start from 0 and it will end at 0. So this is the d hour unit hydrograph. Now what we will do for this value, the assumption is that the response is linear. So both these segments will be linear, and if this base was already the TB value, then this will also remain the same, that is TB. So the base is not changing, only the response that has been varying as per the assumption. So the second graph or the curve, that is according to the assumption, while the first one is the actual response. So if we want the d hour unit hydrograph, this is the d hour unit hydrograph, which is because of the, this is to represent the rainfall. So the rainfall of d hour duration has occurred, and the depth of the rainfall, that is 1 centimeter, that is denoting the unit hydrograph. So in this plot, I'm drawing it again. So this was the first d hour duration, which was having the 1 centimeter of the rainfall, corresponding to which the unit hydrograph was like this. Again 0 values. This is the plot of discharge versus time. Then another duration of the rainfall has occurred, that is again for the d hour. So this value is also d, and the depth of the rainfall, that will be 1 centimeter. So it will start at the duration which is after D time, because once the first rainfall has completed, then the second one will start. Then again the third rainfall has occurred, that is again of the D hour duration, so that will again start at the lag of the D hours. So again we will increase this in this way. Then again if there is another rainfall, that is again for the D hour duration, then again it will start at the D hour lag and it will be like this. So what is happening? In this way we can have the total, if we add up all these values, so this will be 4 times the D value. So for the 4 times of the duration of the rainfall, we have plotted the hydrograph. Now corresponding to this value that I have denoted with this brown color, we are having the two ordinates, one for the black and one for the blue. So we will add up all these values and we will get the resulting hydrograph, which will be like this, ending at this point. So this will be the 4D hour unit hydrograph. So if we are having, let's say, the duration initially 2-hour unit hydrograph, then we can plot 8-hour unit hydrograph or 4-hour unit hydrograph or 6-hour or 10-hour, whatever be the multiple of 2 hours. That means for the D hour unit hydrograph, we can plot the n times D hour unit hydrograph given the condition that n is an integer. That is an important condition. It must not be a fraction, it should always be a integer value. Now one problem is that when we are calculating for the 4 times D hour, so for each rainfall this 1 centimeter has occurred. That means this is not the unit hydrograph, this is the direct runoff hydrograph for the 4 centimeter rainfall. Now to obtain the value of the unit hydrograph, we have to divide it by the 4 centimeter, because for each rainfall 1 centimeter was the excess rainfall, because of which we are getting the direct runoff hydrograph. So for 4D hour unit hydrograph, all the ordinates have to be reduced, and this will be the 4D hour unit hydrograph for the catchment area. So I'm highlighting this. This is the 4 times D hour unit hydrograph. You'll understand this more with the help of the example. Now the next assumption is that time invariance. So two of the most important assumptions are the linear response and the time invariance. What is this time invariance? That it is independent of the variation of the time. The runoff which is produced from a given catchment area due to the given rainfall, that will always be same irrespective of the time of its occurrence. For example, if let's say this is an area of a square kilometer and this is the same area of a square kilometer. Now first of all, the rainfall has occurred in the morning, that is from 8 to 11 am, and then rainfall has occurred in the evening from 5 to 8 pm. Now in both the duration, the rainfall has occurred for the 3 hours, and in the second one also it is for the 3 hours and in the same area. So what will happen? The curve that we will be getting for the 3 hours, that is 3-hour unit hydrograph, that will be the same for both the cases. There will not be a slight change, and this will be shown as the rainfall, that is for 3 hours with rainfall excess of 1 centimeter. That is the second assumption. The third assumption is that the rainfall intensity is uniform over the entire period of the storm. So what we have shown here is the rainfall. So rainfall intensity, that is the depth of the rainfall divided by the duration of the rainfall. So the depth of the rainfall, that is 1 centimeter, and the duration is d hours or whatever may be the value. So the intensity will be 1 by d centimeter per hour, and that is constant over the entire period of the storm. The next assumption is that there should be uniform distribution of the rainfall over the catchment area. That means throughout the catchment area, the rainfall must be similar. It should not happen that at one side the rainfall is more and other side it is not happening at all. So that due care must be taken. Then what are the limitations of this theory? Just now we have made two basic assumptions that the excess rain is uniform over the entire catchment area and the intensity is constant during the entire duration. Now, this is very practical observation that you might have made, that it is not possible to keep the rainfall uniform over the catchment area. It may happen, and it happens, that the rainfall is more in the certain parts of the catchment area, while on the other parts it may be possible that the rainfall intensity is very low. So in actual, these conditions are never strictly satisfied because these storms have non-uniform areal distribution. So that is one limitation. The other limitation is that this theory of the unit hydrograph is valid for the catchment area, which is having as low value as 2 square kilometer and as high value as 5,000 square kilometer. Between these two values, the unit hydrograph is valid. Then the precipitation, that must be from the rainfall only. The snow melt, which is the other form of the precipitation, it cannot be represented by the unit hydrograph satisfactorily. Now, in addition to these limitations, there are certain fluctuations in the values obtained by the unit hydrograph, because of which we do not get very accurate results. So that is also one of the limitations of the unit hydrograph, that we do not get the very accurate results, and because of which the variation in the base of plus minus 20% and in the peak discharge of plus minus 20%, that is considered to be acceptable. If the values are within these range, then they are considered to be acceptable. Then what are the uses of the unit hydrograph? So if we are having the unit hydrograph, we can develop the flood hydrograph for the extreme rainfall. Now what is the use of that? We use that in the designing of the hydraulic structures, because when the entire flood will be coming, that will also be including the base flow also. Therefore, the hydraulic structures are designed for this flood hydrograph. And also we can estimate the flood flow on the basis of the rainfall record. So that is how we proceed in the calculation of the flood hydrograph. Now in the next video, we will try to determine the D-hour unit hydrograph from the D-hour of the given unit hydrograph for the same catchment area. So thank you.